Hello and welcome to another modelling video. This is Alan from the Meconoman at YouTube with another model video. Today we're going to demonstrate the rough assembly of a Creality Ender 5 Plus. Not quite a tutorial. Others have done such an amazing job in guiding you step by step how to put these together. This is more so my experience in exploring this 3D printer and how I've gone about it with the experience I have. This is fairly available. I bought it at a very competitive rate during the pandemic when everyone else was buying 3D printers. Instead of being scarce and sold at an inflated rate, they were incredibly cheap and vying for your money at cutthroat prices. Funnily enough, I was offered to distribute them through my hobby shop, but the margins were definitely not worth it. Customer service, customer support, distribution straight from the warehouse in Australia was fantastic. As you can see in the pictures, the packaging came in this very large heavy set box, a little heavy to carry, with a very dense black foam that had a cutout for every component. No damage or mix-up of parts occurred, as some of the electricals and finer parts are sub-assembled to each branch of the frame. All of it came out pretty well. The next bit is this very comprehensive booklet of instructions. There is a thumb drive with a digital version and a few more details. I logged on to YouTube and found a video that literally held my hand and showed me every step I had to take while orientating the entirety of the 3D printer. If you have some sort of mechanical mindset or used to following instructions a lot like wiring diagrams and plastic model kits, you'll have no problems tackling this 3D printer that you have to build. It's practically finished for you. All you have to do is plug in a bunch of wires and bolt with an Allen key a bunch of metal struts together to create the frame. As it is a cube, it's far more sturdy and it will have less vibrations and produce a more accurate print, but everything is also leveled, and it does make calibrating and leveling it all together very easy. However, with the Ender 5 Plus, it is an absolute massive beast. It clocked close to $1,000 Australia for me. You're looking at around the 800 US mark for people buying it in the other half of the world. All the tools, funnily enough, were included, so I didn't have to get Allen keys or pull out anything special like screwdrivers and whatnot. I have moved to a new house and I have not quite sourced all of my tools yet, so this came across as being quite convenient. It is all well enough machined for a product manufactured in China that all the bolts guided in exactly where they needed to go, and with cable management all the connectors clicked into all the pins that it had to enter. There are many 3D printer products and brands on the market to choose from, and with sufficient research or looking at enough reviews, you'll get the idea of the price point and exactly what you want to buy. Creality is advertised in having multiple sizes and a very sturdy frame, yet low thrills. It is universal and open source enough that you can either purchase parts directly from them to upgrade, or aftermarket parts to speed up the process, make larger dimensions, change nozzles for more abrasive filament, or even build cases to be suitable for ABS and whatnot. Out of the box as is, it's only really suitable for PLA. I bought the biggest model to do the really big prints, which normally impress people. Curiously, the printer I got was not the same as the one in the instructions or reviewed on YouTube, and it had a variable power supply. What was located in the instructions and online would be a switch on the side that you would have to switch for 240 or 110 volts US or Australia, or you're at risk of blowing the whole thing up. The plate was blank. No such switch existed, though through Googling and looking at a thread on Reddit, I confirmed that this make and model, produced much later on from its release, is a variable power supply, and such a fear is not an issue whatsoever. I plugged it in, turned it on, and no magic smoke, no broken 3D printer. Building, wiring, and turning the beast on was a piece of cake. It took me no more than an hour that I was documenting. It's time to make a model. I'm choosing to do Eevee from Pokemon. Simple download from Thingiverse and some very old filaments I've had sitting around from way back with the App Mini. Moisture damaged and absolutely terrible. Tuning and getting this machine to work is a different hat trick altogether according to your experience of dialing in settings and launching. It might be worth to watch a few reviews of other people 3D printing and attempting to make smaller basic models. I always recommend put in some sort of retraction figure, slow down the printing speed, and add a little more heat than necessary. The second issue is also getting the thing to stick to your bed, and that is most always guaranteed a bed leveling issue. You might think by folding a piece of paper in half and running it under the nozzle will get an ideal adhesion. It's not quite the case. There's a lot of factors going on, and this is a very big bed. For your first 3D printer, something far smaller is always recommended. Even though it was my first time at a filament machine for a while, it took me about 4 goes until I got a really nice brim and started producing a model. The first Eevee I scaled it to was 1/4 scale. It was probably about several centimeters tall, nothing too special, and the detail and resolution was not bad at all. The stepping was not offensive whatsoever. Stuck to a clean bed absolutely beautifully. It is glass and adapted to heat nicely. Being used to a primitive, very old second generation machine, having access to such fine control over the heating bed and the nozzle, it was fantastic to see it heat up rapidly and stick very well. I used a feeler gauge to calibrate the nozzle to the bed, and once that was dialed in and the BT automatic bed leveling touch got a sense of where the nozzle was in the real world, it took very little effort in pumping out parts. Once the little Eevee was produced, I sanded away the Z-axis lines and airbrushed it in its shiny form. I got onto what I really wanted to achieve: massive big models in one or a few pieces. I scaled up this Eevee using stats I found on Google, Bulbapedia, of how big this Pokemon was in the real world. The file was loosely based to the mesh being hacked out of one of the video games. I did it at 1 foot or a little over 30 centimeters tall, which is quite a menacing sight when in the studio or bench. The pieces would take about 1 to 2 days at a very thick wall and a decent infill to produce. All the pieces altogether was about 1 week at about 1 and a bit kilos of filament. You can do a speedier print, though I wanted this to be as nice as possible. Melting the Z-axis with a butane torch for a smoother finish and applying car automotive filling products spray putty out of a can and sanding it back with a multitude of sandpapers, I achieved an excellently smooth finish that took well to rattle cans and airbrushes. As I was experimenting, I failed in a couple of bits and ceased printing around the torso and the bib, just being playful. This wasn't an issue as I resliced the part and 3D printed the second half, gluing and putting the two sides together. In the 3D printing community, this would be called a failed print. For little scale modelling magic, it looks pretty decent. Here are some photos after being painted and top coated in a grass field or the wild. Now you've got to really not be fearful running your 3D printer through the gauntlet. This thing needs to do 20, 30, 40 prints until you get a real feel of it. Some of it a bit repetitive. And I did some letters for my shop front. One of the mistakes I made, I didn't clamp down the glass bed and it just slammed right into the nozzle, bending and nearly breaking the BL touch auto sensor. This couldn't really be imported affordable except for buying the whole kit, so I re-super glued the part, and at the moment using the replacement that came with the kit. This is the first consumable or fault I came across of my own doing. The second issue has to do with thermo runout, which is a very important factor to 3D printers and something the newer Creality 3D printers have access to. Thermo runout is when the heat sensor is not sensing how hot the bed or the nozzle is getting. Something mechanically goes wrong, it overheats, it runs out, and it melts, burns, starts a fire, damages your 3D printer, or worse, something can occur to your property. Now, the thermo reader broke, and this happened due to me disassembling and reassembling the hot end head and really destroying the wire, which requires such a gentle screw out and screw in when pinching it. I absolutely ruined it. Bought the cheapest thermo reader off eBay. The downside is this part breaks stupid easy. The good side is, if you're willing to wait for shipping from China, you can buy a massive amount of these very, very cheaply. They seem to be consumable, they break very easy. It's worthwhile ordering a ton in advance and having it on standby, as after your first dozen or so prints, they will require replacing. And don't be fearful on saving money and re-crimping them back to the original connectors, though this printer does work pretty safely. I found the filament runouts to be very problematic with cheap filament. If it's not even, it's going to detect as a runout. Quality filament is not a problem. When the filament actually ran out and I tried to feed new filament in, it wasn't quite touching or pushing, and I air printed it for a while. It's best to keep pushing the filament out until you see a extreme amount of extrusion and you know it's nice and deep inside the hose. This beast is quite a dust magnet, doesn't like too much dust. I found after a while the bottom fan started struggling and needed replacing, though the top fan also got gunked pretty quickly. I've got a maintenance regime of cleaning them out pretty regularly, though I think an enclosure is far more relevant, which is on the agenda. The best and most impressive aspect of this 3D printer, or any of the Creality ones, are that it's so popular. There are so many tutorials, videos, advice boards and whatnot. Any possible fault you can come across, simply googling the make, model and potential fault will lead you to a whole collection of ideas and quick to long-term fixes. There's also a massive library of all sorts of aftermarket parts you can get to improve or use your machines for outside its pre-manufactured scope. I've just ordered some tungsten and hardened steel nozzles. I understand a 0.6 gets the same detail as a 0.4 but has a stronger bond and prints far quicker. An interesting wrench for quickly changing out the nozzles. A fantastic photo tent style enclosure that retains heat and is a little bit fire retardant. Plus all sorts of hot end assemblies that have far greater improvements in performance, plus tubes, hoses and other sensors for remote printing and general better overall operating experiences that the core materials here does not quite offer. It gives a chance for you to enter as a beginner, and as you grow with the printer you continually upgrade, tinker and improve to, if you wish to be a professional, to an enthusiast. Anyone who has spent any significant time on a social media group or a forum around a particular 3D printer or 3D printing in general that attracts a lot of beginners, regardless of the price range and the quality of printer you buy, as a beginner entering, you're going to hit all sorts of brick walls, and you're not necessarily buying a machine that works immediately out of the box, but more so a kit in learning an entire new skill set. You're going to be tinkering, learning, studying, playing, making mistakes, and having successes as you go. Your up to first attempts at bed adhesion is going to fail. You might swap some parts around, and after a few initial successful prints, and as the printer vibrates its way out of calibration, you're going to have ongoing faults and part failures until you start getting the hang of repairing, pulling apart, putting back together, and finding the ultimate settings that produce some wonderful prints. A second problem you'll learn is the downloading, orientating, and supports of models, which is a different topic altogether. And just because it exists in the digital space does not mean it can be created in the 3D and natural space. Do things that are less ambitious and easy tutorial models, such as a Benchy, and work your way up. Don't be quick to ask for help immediately. Utilize Google and see if other people have fallen through the same pitfalls, and find some very handy write-ups, blogs, or videos before getting the attention of an expert to hold your hand and help you out. There's a lot of very talented 3D printers in the community, and they're all very happy to help. In return, once you've reached a certain level, you share your work and throw in your hat to educate others as well. It's a wonderful community. Thank you very much for watching. As always, until next time, stay tuned for further content. Please look at the social media links down below. I hope you've enjoyed my giant life-size Eevee. It is very well enjoyed in the store and already have been sold. My next project will be pushing this printer even further and reviewing more of its limitations in much larger prints, including cosplay items such as wearable helmets, props, and armor, which is I'd like to venture in that direction. So expect more content regarding this machine. Catch you guys later.